Welcome to EF Portal. In this video, we'll explore the portal from an administrator's perspective, from portal customization to advanced services publication and monitoring. EF Portal is designed to make administration of complex HPC workflows simple and accessible, all from a single interface. But first, let's log in. At any moment, remember that you can click on any chapter in the play bar of this video below to quickly jump into the sections that are relevant. Also, make sure to check out our AI support portal featured right at the end of this video. To begin with, we will switch to the admin view by clicking the button in the top bar. Doing this, you can easily alternate between user and administrator interfaces. One of the most important parts of an HPC portal is creating and publishing services that users will be able to run HPC jobs with, and this is where we will start. In EF Portal, a service is a job submission form for users to execute jobs in a simple way, right from the portal's interface. EF Portal allows you to create any kind of service: compute services, embeddable services, file actions, interactive desktops, integration services, monitoring services, etc. In our service list, we see that some services are already available in the portal. Published services are available for users to use, while unpublished ones are only visible on the administrator's side. Of course, it is possible to only publish selected services to certain groups of users, and the availability column shows which services are available to who. Let's start with the creation of our first remote desktop service. EF Portal integrates the DCV remote desktop solution very deeply, and makes it very easy to manage VDI services natively. We will make use of that, so in the services section, let's create a new service. One of the benefits of DCV being integrated to EF Portal is that we can use a predefined template to create our service for Windows or Linux environments. Let's say we'll select Linux for this one and hit Create. Our draft service is ready to be configured. Let's click on Launch Session to edit this action. This panel lets users configure the session's properties, scripts, and other parameters. Everything was already set up by default in the template, so we can leave these as they are for now, close the config window, enter a custom name, and save our new service. To make it available to our users, we can now publish it. After selecting the appropriate user group, of course. If we go back to the user view, we see that it is now listed in our available services on the left. Let's start the session and check that everything works as it should. Everything looks good, so let's close the session and go back to the admin interface. Since EF Portal 2024.1, it is possible for administrators to edit services on the fly without having to republish them, therefore maximizing service availability for users throughout the change. Now that we have successfully created a remote desktop service, let's do the same with a compute job service, a typical use case for users of HPC resources. Let's hit New and select an appropriate template. Bear in mind that templates can be used out of the applications they have been created for, but they can also serve as blueprint to create your own customized services for other applications. Today, we are going to create a fluid simulation compute service using the ANSYS application. Let's click on Create. We can already see that this services form contains more fields than the first one, with text fields, file inputs, option lists, etc. It's a good starting point, and we will utilize it to create our custom service. Working with the form editor, we can rename the service to our actual use case. We will also change the project name input into selectable actual projects by using a radio block, like this. The content of these two fields will be stored in an environment variable, visible in the properties pane, which value we will use in the services script. We now have to adapt the accepted input file formats for our StarCCM service, which are different from the existing template made for ANSYS CFX. This field allows users to pick up files from the remote machine, but you can use an upload input to allow users to pick up files from their client machine as well. Since we are not using CFX for this service, remove the CFX version selector input. And lastly, we will update the number of core static list and update the values to our use case. Now that our form is all set up, let's check out the submission action script that runs when users press the submit button. Several parameters are available here, and we're going to focus on the script itself.
These functions will run for every user submission. And in our case, we have to comment out the CFX version variable line here, since we are not using CFX for this service. The JavaScript section represents the commands at the application level, and we notice that CFX variables are called in this script. Let's remove all the CFX solver-specific parts of the script, and write down the StarCCM commands instead. Here it is. Bear in mind that instead of running an application command here, we could also point to a shell script that would take care of it instead. Now that all our scripts are in place, we can close the action, save our service, and test it by using the test run button at the top. We will fill the submit form with relevant information, input files, and configuration options. Upon hitting the submit button, we will be redirected straight to the spooler section, exactly as if we were a regular user. All good! We are now ready to publish the service to our users, as we did before. Let's create one last service, of a different type this time. A Tecplot file action service, to plot the results of a CFD analysis. This time, we will create an empty batch service completely from scratch. We will add a title to our service, and a remote file browser to pick up an input file. After we've done that, let's head to the action script, where we will make sure that all lines are commented out for a fresh start. First, we will point to our Tecplot applications path and add the inputs variable from the file browser we added to the form earlier. Okay, now that the action script is set, we'll head to the service's settings and activate the file action option. We're ready to save and close the edit page, publish the service, and switch to the user portal to test it out. We see that our new service is now available in the list, and we can try to start the Tecplot action on a file from within the file manager. Let's select an appropriate file, and we see that our new service is now listed in the Actions dropdown, ready to be used right from the file's context. That's it for services. Let's move on to infrastructure and host management. For this, we'll take a look at the infrastructure pane on the left. In EF Portal, the clusters page lists available clusters in our environment, a view that is only accessible to administrators. The hosts page displays all the computing nodes or servers that are available for running computational tasks. This page is viewable by users, and we may want to only allow specific hosts to be displayed here. Let's open a terminal and navigate to the configuration folder. From there, we can add a custom regex rule to the host filter config file, like this. We can also set this custom view as the default view in the hydrogen comp file. Now, if we go back to the hosts view from the user side, we now see our custom view by default, or in the filters pane on the right. Let's move on to the next part. Since release 2025.0, if we select a host, we see that quick commands are available in the top bar like PS, top, free, etc. As an administrator, we can edit these quick commands or add new ones from the host commands configuration file. In our example, let's add the W and hostname commands for our users by uncommenting these lines and check that our new commands appear in the top bar afterwards. Another recent addition to EF Portal is the ability to launch web shells straight from the user interface. Still from the host view, you can simply hit the terminal button from the top bar. This command line interface lets us interact with the host directly for various operations. Administrators can also customize the terminal in the shell environment's configuration file. Okay, now let's move on to workflow automation with EF Portal. Version 2025 Chem 1 introduced pre-submit and closing hooks. These are useful additions if you need to power on a machine before launching a session, or shut it down afterwards, for example. These hooks let you automate such actions, making your infrastructure more responsive and cost-efficient. Hook scripts can be configured using the interactive conf file shown here, which we can edit to add starting, closing, and pre-submit hooks. One important note, pre-submit hooks are not blocking. They're executed asynchronously when a session is in a pending state, and if the hook script fails, the session won't be submitted and will move to a failed state. Another major recent development in EF Portal is the REST API. This modern API replaces the legacy web services approach, so you can extend automation towards end-to-end HPC automated workflows. The API's documentation can be accessed from EF Portal's welcome page, where a redoc lists the most important endpoints. The portal also ships with a Swagger interface for you to test all available REST endpoints. Let's try a few API requests. We can, for example, make a call to list all our available hosts. We can also list all our jobs, retrieve job details using a job ID, list currently logged in users, etc. Of course, this API allows us to interact with services as well. Let's list all services first, with the services all command. Now we will submit a job by using the service post command. In this example, we will submit a file compressed batch job. To do so, we need the service's SDF and URI information. Then we specify a spooler, input file, compression value, and cluster. After that, we can send the API request and our job will start running. The API will respond with the spooler's URI where the job is running, and we can use this to check our job status both in the GUI or using another API jobs call. And here we see our compressed job currently running on the cluster. Let's refresh the compute status, and it is now completed. So we have done all this by querying the REST API with the various curl commands documented in the Swagger doc. But did you know there is another, quicker way to use all these endpoints? EF Portal is also equipped with a full-fledged Python client called efpclient. You can install it in 2 minutes by using a simple pip install. Once installed, the client lets you interact with the API in a very handy way. For a quick try of the endpoints we have already demonstrated, we can list all the hosts, list all jobs, list services, submit another compression job, retrieve the spooler's contents, and even download our result compressed file. The efpclient documentation is available at the link shown on screen. This was a quick tour of EF Portal's workflow automation capabilities. At NISP, we believe that offering HPC professionals a portal environment that looks and feels truly customized to their identity is extremely important. Since version 2024.1, EF Portal now features a built-in CSS editor, accessible from the Appearance panel in the admin view. From there, administrators can add a custom logo, choose among several predefined color themes, and write their own changes in the CSS editor. No need to fiddle with hidden configuration files anymore. Let's move on to the access and security features of EF Portal. From the Users panel, administrators can register, import, export, and edit users. It is also possible to create groups of users for easier management of permissions and roles. From the operational dashboard, admins can also monitor logged users and their currently active license tokens. In EF Portal's recent releases, new security controls were added. Admins can now monitor login and logout events by enabling the audit-like call parameter in the server's config file. After activation of this parameter, admins can check out the audit log file to monitor user activity. It is also now possible to control file previews and file downloads more finely. Let's head to the FM download configuration file. Adding users to this file will enable downloads permissions, and only users listed here will be allowed to download. Now let's talk monitoring. EF Portal provides a lot of observability functionalities for administrators to stay in touch with their HPC environment. First, let's come back to the portal's menu page and go to the operational dashboard. From this page, admins can access various metrics like live and historical server load, usage statistics, licenses, installed EF Portal components, triggers, ACL actors, etc. From release 2025-1 onwards, monitoring capabilities of EF Portal have been greatly expanded, thanks to the addition of StatsD support, which make it very easy to plot monitoring data in Grafana. Administrators can now stream detailed EF Portal metrics, such as CPU, memory, jobs, file systems, and licenses, directly into StatsD and visualize them in Grafana or other modern monitoring tools, as shown here. This extends the built-in RRG graphs with scalable long-term observability. That's it for today's admin demonstration of EF Portal. To revisit the concepts shown here and explore all the advanced features of EF Portal, you can go to our brand new support portal at ni-sp.com/support. Make sure to check out the new AI support tool to ask any question you like. Don't forget that you can request a free trial of EF Portal at any moment on our website. We wish you a smooth HPC journey, and if you have any questions, don't hesitate to reach out to us at ni-sp.com.